Hello, tensor friends. Yesterday we were looking at the Riemann curvature, the tensor of a paraboloid with this equation. We parameterized it. We identified a position vector based on these parameters. We took its derivatives. We found our basis vectors, and then we found our metric, the tensor. Most of the metric tensors you see, these off-diagonal elements are zero, so it makes it really easy to take the inverse because we needed the inverse of this to continue with our problem. And this one's obviously not. So the inverse of this is hard, and it looks like this. And I was looking at these this morning, and I noticed a pattern. I'm going to put them side by side. Here's the metric tensor. Here's its inverse. Do you see how this is here and this is here? And these are just the negatives of this. They all have the same denominator. And literally, a light bulb went off over my head like they do in the cartoons. In my mind, I traveled back to something like 1975 in linear algebra. I remembered there was a very easy way to take the inverse of a matrix, and that was this. The inverse of a matrix is equal to its adjoint, I believe this is adjoint, of that matrix divided by its determinant. And I had to look up how to do an adjoint because I don't remember. It's been a long time. So the easy way to do that, if this is your matrix ABCD, is the adjoint of that, or adjunct. Adjoint. I think it's the same thing. You swap these two and take the negative of these two. Swap these two, take the negative of these two, and that's it. So here is our metric, the tensor. So we take the adjoint of that. So we move this here, move that up there, take the negative of these two. We had already found, working with our problem, the determinant of the metric, the tensor, was this. So we put all of this over top of that, and bada bing. Because it really bothered me that I looked this up on an online matrix calculator, because I come from that age where, we didn't have computers, we didn't have anything. We had pencil and paper and a slide rule. So I always feel like I'm cheating when I look something up on an online calculator. So anyway, I'm glad I remembered this because it really makes it easy in doing these problems. So if you didn't know it, there it is. If you did, you probably did. All right, see you later.